My name is Michael Schmidt. I'm the program director for Long Live the Kings. I'm also the coordinator for the Sailor Sea Marine Survival Project on the Puget Sound side. The Sailor Sea Marine Survival Project is a joint effort to look at what's affecting the survival of juvenile outmigrants of Shinnecoe and Steelhead as they exit their rivers and go through the Strait of Georgia, Puget Sound, and somewhat through the Strait of Netified. And then Ed Connor will go next, and he can introduce himself when he goes. I'm going to just talk briefly about the broader effort around Steelhead and Puget Sound, and Ed will help put it in the context of the schedule a little more. I'll put some in the context, but we'll go from there. So this is why we're looking at marine survival of Steelhead and Puget Sound in part. I'll show a couple reasons, and yes, this is hatchery fish, but this is all hatchery fish, Washington Coast versus Puget Sound. And it's just being used as an indicator of differentiation between the coast and Puget Sound. And as you can see in the late 90s, and I'm sure you guys have talked about this a lot, but there was a decline in survival across the board, and that was throughout the North Pacific, at least south, the southern North Pacific. And then here you see that the Steelhead and Puget Sound on average didn't quite follow the trend of Washington Coast. You see a little bit more of a recovery. And this is the yellow bars, and the line are just showing the difference, basically, that the difference in survival has gotten greater for Puget Sound. So it looks kind of like the Puget Sound fish aren't quite, reacting to only variation in the ocean. And so this is more evidence of the issue of mortality in Puget Sound. This is just showing the smolt adult survival of all wild. These are all wild steelhead. Of steelhead from 6 different rivers over a 4-year period. This is all acoustic telemetry data that was compiled by Megan Moore from NOAA. And what it's showing is that most steelhead don't survive, 80% of the fish die before getting out to the Strait of Netified, and that's within 2 to 3 weeks. So it's rapid. You're seeing fish die quickly, and you're seeing a lot of them die relative to the entire population going out. And then you also see a south to north gradient in survival. So Nisqually fish seem to survive worst. And then as you move up, to some extent, there's a little difference here in Skokomish and Big Beef. But basically, the farther you have to go through Puget Sound, the more you succumb to mortality. And so around this, there was a collaboration put together to focus on the steelhead component of marine survival. There's actually about 40 collaborators on the entire marine survival project, and there's about 10 or so on the steelhead component. And there was work trying to weed out exactly what to prioritize for research, and this is just reflects the thought process that was put into what to make decisions on what factors to focus on. And the first one was to ask the question of, first you have to differentiate between proximate and ultimate mortality. Basically, how are the fish dying, and then maybe what's leading to that mortality. And the first question is whether or not predation is driving, or is the proximate cause of mortality. Are these fish dying, just dying, and or are they getting eaten? And then ask whether or not predation is the direct cause or some environmental factor associated with predation is a cause, or whether it's something to do with fish condition. And in the ranking of fish condition, and this is all kind of weight of evidence, basically look at what we know about the fish. And the group who worked on this weighted what they thought the factors might be. And as far as condition related, it was disease, water quality, fitness, and then harmful algae, foraging starvation, and size and timing down a little farther. And most of the factors were tested regardless of this approach of categorizing, but this is how we framed, or how the group framed the research to ensure that they were putting the most effort in the things they thought were the most priority. So what was done? The group assessed the correlations between survival and ecosystem factors and fish characteristics. They also tried to better identify the locations, rate, and timing of mortality, and then primarily focused on disease, toxics, genetics, and predator-prey interactions to try to get at that, what's the direct cause of mortality and what's the underlying. And this is just I'm going to go through some findings. This is all work that was done by the scientists involved in the group. I'm just doing a couple slides on each piece and trying to keep it pretty high level. This group will be presenting their findings at the Salmon Recovery Conference in May, and then also at American Fisheries Society meeting in August. So this is just work done by Neela Kendall to try to get a handle on general correlations between steelhead survival from Puget Sound and different factors where we have the data that we could do this. And this is incomplete. This is looking from the 90s forward, so it misses some of that, bigger decline where we want some additional information. But the largest correlations with this data are coastal upwelling, which you'd expect from a ocean-driven survival, and then locally in Puget Sound, it's herring abundance, basically a positive trend, more herring, more steelhead survival, and then seal abundance in particular, having an opposite correlation. So one of the studies that was done was called a reciprocal transplant study, and this is again not Skagit, this is south. And what this was doing was trying to weed out again whether or not your survival is driven by a marine component or a freshwater or population component. So what was done was there were two rivers, the Green and the Nisqually, and you had a home and an away team for each one. And these 50%, and these are all wild fish, 50% were released at home. They were acoustic tagged. These were all acoustic tagged. 50% were released at home and 50% away, and switching the two rivers. And the idea here is to try to get at, again, whether or not there's a population or river of release effect. And doing that because if you release a population out of context and it survives worse than the other population, well, it could be a translocation effect or it could be population or river effect. If they survive the same, then it's more likely that there's a marine effect. And they generally survived the same through the courses. And I'm just showing you kind of, again, how it was set up. And the mortality for both groups tended to be in that front period, right when they were entering the marine environment. The bulk of the mortality was there. And then through Puget Sound to about Admiralty Inlet. And this is consistent with previous studies that show most of the mortality, at least from the acoustic telemetry data, was in Puget Sound proper and not into the Strait of Juan de Fuca. And this is just some anomalous activity on some of these tags, which may help indicate what some of these driving factors of mortality are. A few of the tags out of the Nisqually had this back and forth movement. And what this is just showing is that the tag was moving in and out of the river. And most steelhead don't do that. They typically shoot right out of the estuary and out. And so that movement was generally associated with the tides. And it was suggested by some of the marine mammal folks involved that if you see some sort of tidal relation, a predator that moves into the river during high tide are harbor seals. So this tight correlation with the tag movement with the tides could suggest something like it was predated by harbor seals. Hey, I'm going to just put all these out. So, and I'll just quick over the conclusions of this one. The survival probabilities were low for last year. It was 17% outmigrant survival from anything that was leaving the Green, and then 6% for those that were leaving the Nisqually. Population, river, translocation, and length factors did not help describe variation in survival. And this is the other part of, when you're looking at the Green versus the Nisqually. The Nisqually is a relatively restored, intact system. It has no hatchery influence. The fish are big when they get out of there. When you look at the Green, it has hatchery influence. It's an urban stream, et cetera. So you're looking at definitely difference there, but that is not playing out in the marine environment, at least according to this data. And release date, when they left and into the marine environment and when they went through the marine environment, was somewhat of a predictor of survival, but it wasn't as much as release location and migration through the system. smolts took a similar amount of time from release to the Strait of Juan de Fuca, again 2 weeks. And the highest mortality rates were in the first marine segment. And then we were just talked about that behavior in the estuary may help kind of isolate some of those causes of mortality. So to try to start getting at this predator question, like what might be eating steelhead, there was work done by Scott Pearson at DFW to say, okay, what might be those top predators? And this is based on looking over data of the presence of the predator during the outmigration time of steelhead, gape size, can the steelhead fit in the mouth of the predator? And I think that those were the two main ones. And so the top predators suggested through this are the cormorants or harbor seals, and secondarily harbor porpoises and common murre. And the other one is how has the abundance basically changed over the time period of the decline of steelhead. And more so harbor seals and porpoises than common murres and cormorants, but they haven't declined per se. So you have a definite upward trend in marine mammals. And so one piece of the work looked at the harbor seal and seals relationship, and again, because there is this substantial increase in the number of harbor seals in Puget Sound over that same time period of a decline. And harbor porpoises kind of did that same thing, and that is something that's still of interest. However, trying to tackle a harbor porpoise is different than trying to tackle a seal. So the work that was done on comparing and looking at the harbor seal steelhead interaction was done with putting these receiver packs on on harbor seals, and then acoustically tagging the steelhead, so you could look at interactions between the two. And 12 seals were outfitted with these acoustic receiver packs, and then 240 steelhead had acoustic transmitters. And the main purpose of this was just to look at whether or not they coexist in the same area as a starting point. Do you have seals and steelhead encounter in the region? And the thought originally was that you might, and you might see something. What we found though was that there was a very high level of detection between the two, relative to what was expected at least. And these are the number of pings based on what the seal was picking up. And the reason why even the encounter rate is compelling is because of the distance, and I'll show in a minute, of the ping that can be picked up by these seals. Oh, and some of you are going to ask about the dinner bell effect. So I'm going to quick go back here. So there's this delay ping here, and there's this issue of whether or not if that harbor seals can hear the ping, does that actually affect the predation rate? They can hear the ping, we know that, but does it affect the predation rate? So there was a group of fish tagged, but the ping was delayed as for the time period that the fish would be going through Puget Sound. And then the mortality rates were compared, because you can actually, the ping turned on after Admiralty Inlet or at about Admiralty, so you could actually compare the rates of survival, at least to the Strait of Juan de Fuca. And there was no effect of differentiation in survival on that. So anyway, lots of pings, which suggest a number of encounters. This just shows the seals. They were at Cobalt Rocks and Orchard Rocks to the south, and just shows the relative foraging patterns of the seals to give you an idea of where they were. Most seals hang out mostly around their haul outs and forage locally. Some distribute out farther. And of course, it was the ones that kind of went into the sound a little bit more that provided more data. And this gives you just the conditions that are required for a seal to pick up one of these tags. They have to be in about 100 meters of the fish to get it, and they can either get it if the fish is swimming through with the tag, or if the tag dropped out. If they're above water, they can't, because it's acoustic, so it has to be subwater. If they're out of 100 meters, they can't. If they're swimming at the top, they can't. So it just gives you some idea that the relative range has to be pretty close. And this just shows you the encounter rate. So for Nisqually fish, about 58% of the smolts that could have been detected by seals at the time that they were entering the area of seals were actually detected. And then if you're looking at the green and Nisqually smolts, about 27% were detected by those central Puget Sound seals. And then 12% of the smolts were detected by Koval seals. And this is consistent with fish dying as they move out of the system, and more, obviously, the Nisqually spending more time in the area of the seals. So it just, again, shows that they are using that same area. And then trying to get at whether or not there's actually mortality occurring. Now, there were no seals in this that you could say we saw direct mortality, like a seal eating a steelhead. You didn't have the telemetry line up as such. But you did have these tags that ended up getting multiple pings in isolated locations. And it's evidence of a tag that's dropped out or a fish that's died. And these had occurred at haul-out sites, and there were a number of these. And this is starting to present an approach to getting a handle on what that mortality rate is for seals by steelhead. So now, what is the role of fish condition? So we've kind of looked at direct predation. If they're being predated upon, which it does obviously seem to be, is it just because of the predators, more predators in the system, maybe environmental factors that have changed, or is condition playing a role? And there's a Genomewide association study being done. This is going to look at the survival of various fish that were acoustic tagged over that 2006 through 2009 period, and actually a few new fish, to look at whether or not again, there's something to do inherently with the fish that could have been leading to greater or less survival. So this will, again, get at population characteristics and get at that fitness question again, which a lot of you talk about with the hatchery wild piece. And with fish health here, there were two components looked at, again, disease and toxics. And to narrow down the disease scope, we had a group of about 20 scientists get together in the fish health and physiology department, and they decided that based on the survival difference as you go from south to north, that gradient was very consistent with the presence of Netified in the system. It's a parasite. It's basically what makes your dog sick if they eat salmon. It's a parasite that gets into the system through snails that are mostly present in these southern rivers, and can get into fish. And there was substantial evidence of Netified in coho, but there wasn't much known about Netified in steelhead. So there was a large-scale collection done starting from in the river at smolt traps down to the near shore and into the marine environment. And we were very skeptical about our capacity to catch steelhead in the marine environment. But we used the purse seiner, the same platform we were using for Chinook and coho, and actually caught a number of fish to test, and in all the areas that we were looking. And at the fewest, I think it was 4 or so. But at least you're starting to, again, get an idea of what's going on with these fish. Before, we didn't really have anything. So this is showing Netified trends, and the important part here, again, is first of all, you don't have Netified in the Skagit. So it's not going to be something that would be contributing to mortality. As you go south, you do have it at pretty significant loads in the green and the Nisqually. And what's most important is when you get into the estuary parts of those systems, the prevalence and intensity actually get higher. And there's a differentiation between the in-river versus the downriver, which means that they're picking it up as they get down into the system. And what is being studied next is there's evidence that shows that within the 2-week period after getting the infection in Netified, the swimming performance of these fish are compromised. It's because the parasite actually burrows through the muscle tissue, and while it's burrowing through that muscle tissue, it's actually making these fish weaker. So if Netified is compromising these fish right before they enter the marine environment, they could actually be more susceptible to predation. Now, why is this consistent with what I showed you with the reciprocal transplant study, saying that there was no population effect? The reciprocal transplant study was looking at fish population effects from river kilometer 19 up. It was the trap and up. It wasn't down. So the estuary is included in that part where you could say there's a differential difference in survival. The other thing too is both the green and the Nisqually have nanophytes, and they do contract more in the lower river. Now this was the contaminants work done, and this is again to show you the Skagit versus other systems. And this is looking at PBDs in Chinook versus Steelhead. And what this is showing again is that there's not substantial contaminant levels in the Skagit system fish. So there's not a big burden there. It doesn't suggest that would be influencing survival. In some other systems, though, the PBD levels are higher, like the Nisqually, and that was kind of a surprise to the folks down in the Nisqually to have higher levels of PBDs, and that's going to be investigated. But again, it's not, they're higher in Nisqually, but again, for those northern populations, it doesn't seem to have an effect. And now this one is kind of a curiosity, and actually something that you guys could probably provide some feedback on too, is that the lipid content of outmigrating smolts for all the rivers that were looked at were about 1%. And a lot of folks say, well, God, that's low. And what we're curious to try to figure out is whether or not that's normal for that just for that time period of the fish migrating into the marine environment, or whether that's abnormal. And if it's abnormal, then how that would compel going further and trying to answer the question of, is that compromising condition of fish entering the system? If it's normal, just because they're like teenagers, they're going through puberty or whatever, then it's not a big deal. So that one is worth discussing as far as a potential contribution from the freshwater. And again, because you see a profile across the system, you wouldn't be able to weed it out by doing this kind of reciprocal type of study. So this is where we're at. Basically, again, trying to bring this evidence back into, this information back into a weighted evidence scheme. It definitely looks like disease could be playing a role in South Puget Sound. And it's how, now it's testing whether or not that's like contributing to mortality from predation, for example. Water quality, not near as much. Outmigration timing might be, and what's curious now is that the timing showed that the fish survived better the fish that were leaving earlier survived better. So the fish that were leaving late April, early May seemed to survive, and then the survival went down. And we're trying to figure out what's driving that, and there's some questions about whether or not there's some predator-prey dynamic going on that would drive that, and mainly associated with hatchery releases. So, for example, in South Puget Sound, if you're getting this big pulse of hatchery fish into the system, and you're having these steelhead go out, is that large conglomerate of fish in the system actually driving predators to that area, which would then make the steelhead more susceptible to predation. And there may even be some more evidence to support the idea of more predators driving to a certain area, because the biomass of fish, at least if I'm understanding it correctly, actually gets higher in South Puget Sound for a period of time relative to the other areas based on the migration of forage fish, that they're just not as abundant north during that May time period. And then you have a lot of salmon in the south system, and in a lot of that abundance is chum, but it also includes hatchery, coho, and Chinook. So there is this question of whether or not there's this relationship between pulse abundance and survival. There's also, just from long-term trends, again, it looks like forage fish populations have decreased in South Puget Sound, and obviously predation, the number of predators looks like it's increased. And there's a question about turbidity, because it's clearer, the water's clearer in South Puget Sound compared to north, so how does that play a role? And so these are, still factors that are going to be working together, and there will be efforts to weed them out. And on this side, this is just, again, putting them in order. Disease, water quality, outmigration timing we got to. And again, that question about introgression, it just, once the fish are actually getting into the marine environment, it doesn't look like it's a big driver of survival, at least from what we've seen so far. And again, that GWAS study will help answer that question.